Today we are going to discuss another relationship that is regression analysis. Okay, regression analysis, regression analysis, regression, regression analysis. Okay, okay, correlation and regression both are relationship. Basically, some difference between these two terms. In correlation, we have to study what amount of relationship between two or more variables. It is simple, we will two more than, we will call the multiple. In regression, what we are doing is, we have to find what type of relation between these two variables. Clear? So what type means it may be linear or non-linear. Linear means it should be a line. Linear means it depends on line. That means we have to draw a straight line along with these points. If it is possible to draw a straight line among these points, we call it as a linear regression. Sometimes the points are coming in like a curve. So in this case, we call it as a non-linear regression. As in the case of correlation, if you are studying more than two variables, we call it as a multiple regression. Okay, so the difference is that in correlation and regression, in regression analysis, there are two variables x and y. There are two variables x and y. One is independent, other is dependent. Should be correctly, you have to specify it, which is independent variable and which is the dependent variable. Okay, so y may be independent or x may be dependent, whatever it may be the situation likes. Okay, independent variable means we can say a simple example. Okay, sale is depending on the advertisement. Okay, sale is dependent on advertisement, sales and advertisement. Which is the dependent variable? Sales or advertisement? Which is the dependent variable?
Sales.
Sales is the dependent variable and advertisement is the independent variable, because as advertisement increases, sales also increases. So sales is dependent on advertisement. Okay. Okay, the crop of a field depends on many factors. Okay, the fertilizer we are giving, the rainfall we are giving, the labor we are giving, the quality of the seed we are putting the seed, what is a good quality, high quality seed. Okay, in this case, crop is the dependent variable or independent variable?
Dependent variable.
Dependent.
Okay, crop is a dependent variable. Crop is dependent on all four factors I have already mentioned. Okay, in this case, we are studying more than two variables. We call, in that case, we have to apply a multiple regression. Okay, we are studying only two variables and income and expenditure. What is a dependent variable? Income and expenditure. Which is a dependent variable?
Expenditure.
Expenditure is a dependent variable. Okay, if more income comes, we have to liberalize our policies. Okay, so in regression analysis, we are analyzing, you have to specify which is the independent variable and which is the dependent variable. Okay, so actually which is same as sort of correlation. Some difference is that we have to start with the scatter diagram. Okay, first of all, we have to draw the scatter diagram. So scatter diagram you means there are two, what is a scatter diagram? We can study the intensity of the relation or the direction of the correlation between two variables. Okay, so we can take it as sales and here and expenditure here. Okay, expenditure here. Okay, the points are coming like this. Okay, points are coming like this. Okay, some points are here and some points are here. Okay, in regression, we are in the correlation, we are specifying what amount of relationship between the variables and the direction, whether it is positive and whether it is negative. In regression analysis, our aim is to prediction. Okay, we can fit a straight line, and if you know the independent variable, we can find out the dependent variable. Okay, that's the use of regression prediction purpose. So in business analytics, highly used. It's a useful concept. Predictive analytics. It is a predictive analytics. So there are difference between analysis and analytics. Okay, business analytics nowadays a new term comes business analytics. In analysis, we are studying only the past data and nothing we have to. We have to compare with the past something nothing more than that. In predictive analysis, that's important in business analysis. So from the past data, they have to predict the future. Okay, predictive. And one more thing is that a prescriptive analysis, more than that. So using the prediction, so for example, from the rainfall, from the sun, so from the climate prediction, we can high rainfall happen within 1 day or 2 days. What do you have to do? We have to make arrangements. Okay, actions we are taking such a type of analysis, we call it as prescriptive. Descriptive is there, past we are studying, predictive is there, we can future prediction, and prescriptive analysis, we are taking the action from the result. Okay, we will discuss more in a business study class in the third semester. Okay, okay, don't worry. So in regression analysis, what we are going to do is we have to fit a straight line. Okay, we have to fit a straight line. Okay, I am fitting a straight line. So I am fitting a straight line. So the technique is that mid of the curve, okay, in the middle of the all curves, all points, we have to draw a best fitted line. How it becomes a best fitted line? Best fitted line means the distance from all these points. Okay, the distance from all these points should be a minimum. Okay, so we are taking actually what we are taking here is to draw a straight line. We take the average value, average. So we are taking the average along with it. We are draw a straight line. Okay, the straight line is not good. Okay, the prediction is not accurate. Okay, be careful about to predict to fit a straight line. It should be a best fit, otherwise prediction will be a wrong, prediction will be wrong. Okay, I am fitting a straight line here. Any prediction is possible because the distance from the points is very high. So how to find a best fitted line? Okay, how to find a best fitted line means you have to fit a straight line. That means it has some equations. Equation means y is equal to a plus bx. Okay, what actually finding an equation of the form y is equal to a plus bx. Okay, so fitting a curve means we have to fit a straight line among these points. That line should be as a best fitted one. Okay, we can't draw a straight line along these points blindfoldly because some techniques are there, some mathematical techniques we are using. Okay, so there are two variables, there are two types of regression. Okay, in two variables x and y, there are two types of regression. One is y on x. Okay, one is y on x. Okay, in y on x, x is the independent variable. X is the independent variable and y is the dependent variable. Okay, the use of y on x is to predict the value of y for a given value of x. To predict the value of y for a given value of x. Okay, so another equation is x on y. Okay, x on y. X on y, y is the independent variable and x is the dependent variable. X is the dependent variable, y is the dependent variable. So in two variables case, we can fit two straight lines. One is y on x and other is x on y. The aim of the use of y on x is to predict the value of y for a given value of x. In x on y, the predict the value of y for a given value of x. That's the difference between y on x and so why there are two types of regression. A question may ask, you can say that there are two types of regression, y on x and x on y. The use of y on x is to predict the value of y for a given value of x. The use of x on y to predict the value of x for a given value of x. More than that, you can say that in y on x, x is the independent variable, y is the dependent variable. In x on y, y is the independent variable and x is the dependent variable. Okay. Usually, the regression equation y on x is always of the form y is equal to a plus bx. Okay, y is equal to a plus bx. And regression equation x on y is of the form x is equal to c plus dy. Okay, x is equal to c plus dy. Okay, this is the equation. A and b are constants, c and d are constants. That can be, we can find out from the, we can be found from the data. Okay, you can find out the values of a and b. Okay, so the trick or the best fitted line, I already told you that it is practically difficult to draw a straight line. Okay, you can't draw a your own way because the distance is very high. The accuracy, it has no accuracy. So for that purpose, some mathematical technique we are applying to find out the best fitted line. Okay, okay, I am going to erase okay the recursive equation y on x. How to fit a recursive equation y on x from the data. Okay, some mathematics techniques, some of you are familiar. Okay, y is equal to a plus bx. Okay, y is equal to a plus bx. That is a regression equation. Okay, so what we are doing is, okay, this is the point. Okay, these are the points. Okay, these are, so this is y is equal to a plus y is equal to a plus bx. Okay, this is the equation. And we have different values. What we are doing is that we have to take x values. Okay, whatever it is here, it is a sales, and here it is expenditure. Okay, sales and expenditure. Y on x, so we can take y here. Okay, sales here. Okay, this x on. Okay, sales and expenditure. Okay, expenditure. Okay, so for each expenditure we get the x here. Okay, so here also with this weighted line, for each value x we get a point. So our aim is to find out the distance from the central point. Okay, the distance from these points. Okay, we have to take it as, so it is some distance from this point to this and this point. So you have to find out the difference. What is the difference? Okay, that is equal to y minus y y minus of y hat. That means estimated value. That is all the whole squared. Okay, to find out, so our trick is that the difference between the original value and the fitted straight line value should be minimum or maximum. Should be minimum or maximum. We want
Minimum,
a
sir.
fit best fitted minimum. Okay, the difference between the original value and the expected value, already fitted value, should be minimum. Okay, and adding all these, the all values of the distance should be minimum. Okay, sigma y minus y hat over squared is minimum, or sigma y minus of a plus bx. Okay, the whole squared is minimum. Okay, this is a trick we are going to apply. The value should be minimum. Okay. So for that purpose, a technique in calculus, some of you are familiar with the calculus, plus two students and BTech students and science students know what calculus. Okay, plus two, you have calculus. In that case, how to find out maximum and minimum using method of derivatives. Okay, first derivative is equal to 0 and second derivative should be negative. We say that the point is maximum. That technique we are applying. You don't worry about the mathematical tricks. By the technique of calculus, so we will get two equations. Okay, we want to minimize, so dos by dou a, and two derivatives we are taking and equated to 0. We get two normal equations. Okay, the normal equations are, our equation is a plus bx. Okay, how to write the normal equation? Sigma, you take it as sigma y is equal to Na plus Na plus b sigma x. That's the first normal equation. B sigma x, or sigma xy is equal to a sigma x, okay, plus b sigma x squared. Okay, b sigma x squared. Okay, first we are taking dou s by dou a is equal to 0. We get the first equation. Second, we will take a dou s, derivative of partial derivative with respect to b, we get a second equation. Okay, so two equations we got each, including a and b. Okay, So from this, sigma y, we take the all y values. N means number of observations, and sigma x, adding all the values of x, and xy, adding all, we get a sigma xy. Sigma x, we know that. Sigma x cardinal. So we get two equations. Solving these two equations, we get the values of a and b. Okay, we get the values of a and b. Let a is equal to 3 and b is equal to 5. Okay, so equation becomes y is equal to 3 plus 5x. Okay, so you don't worry about those the mathematical technique. What you have to do is you have to solve these two normal equations and we get the values of a and b, and substitute here we get a y is equal to 3 plus 5x, which is the best fitted equation. Okay, then you draw this equation. We can see that the straight line is coming the middle of these all the points. Okay, the distance is very high. We can check the distance is very high. That curve is not suitable for prediction. Error is very high. Some other techniques are there to check the accuracy of the curve. You don't worry about. Now we are discussing only how to fit an equation. Okay, these are the techniques you apply for fitting a regression equation. You have to remember. Let the regression equation y on x be y is equal to a plus bx. The normal equations are sigma y is equal to na plus b sigma x, and because xy is equal to a sigma x plus bx squared. Okay, and adding all these values and solving, we get the values of a and b, and substitute here we get a 3 plus 5x. Okay, from this equation, if x we know, we can predict the value of y. Okay, that's use of recursive equation on y on x. Similarly, we can find out the recursive equation on x on y. Okay, this is the method for finding fitting a straight line of the form y is equal to a plus bx. Clear? Okay, we can do a simple problem. So um, please write something. Okay, please write something for you. Regression analysis. There are two types of equations in. There are two types of recursion equations. There are two types of recursion equation. There are two types of recursion equation. One is y on x. One is y on x. One is y on x, and other is x on y. One is y on x, and other is x on y. One is y on x, and other is x on y. The recursion equation of y on x is of the form y is equal to a plus bx. Y is equal to a plus bx. The regression equation on x on y of the form x is equal to c plus dy. The regression equation on y on x is of the form y is equal to a plus bx, and x on y of the form x is equal to c plus dy. In y on x, x is the independent variable. X is the independent variable, and y is the dependent variable. X is the independent variable and y is the dependent variable. X is the independent variable and y is the dependent variable. The recursion equation of y on x is used. The recursion equation of y on x is used. The recursion equation of y on x is used to predict the value of y, for a given value of x. Given value of x. The regression equation on y on x is used to predict the value of y for a given value of x. In the regression equation of x on y, in the regression equation of x on y, in the regression equation of x on y, in the regression equation on x on y is the independent variable, y is the independent variable, and x is the dependent variable. Type your name in the chat box, okay. X is the independent, in x on y, y is the independent variable and x is the dependent variable. The regression equation of x on y, the regression equation of x on y is used to predict the value of x, for a given value of y, the value of x for a given value of y. Okay, completed? Hello, completed?
Yes, sir.
Yes, sir.
Okay, okay. Consider the regression equation on y on x. Consider the regression equation of y on x. Consider the regression equation on y on x. Y is equal to a plus bx. The normal equations are sigma y is equal to
So the normal
NA.
equations.
The normal equations are sigma y is equal to Na plus b sigma x. I have given the I will give the notes in the, you can see the notes, the detail how it is coming. Okay, sigma y is equal to Na plus b
Sir,
sigma
Na
x.
plus
Case number one. B sigma x, b sigma x. Okay, case number 1. Then easy method I will give you. You have to multiply with x. We get sigma x y is equal to a sigma x plus b sigma x squared. Okay, sigma xy is equal to a sigma x plus b sigma x squared. Okay, these are the normal equations of y on x. Okay, sigma y is equal to Na plus b, n is the number of observations, Na plus b sigma x, and sigma xy is equal to a sigma x plus b sigma x squared. Solving these two equations, we get the values of a and b. Solving these two equations, we get the values of a and b. We get the values of a and b. Substituting the values of a and b. Substitute the values of a and b in the equation y is equal to a plus bx. Substitute the values of a and b in the regression equation y is equal to a plus bx, we get the best fitted line. We get the best fitted line. Okay. Okay, we can fit an equation. Okay. Please write a question. From the following data of values of x and y. From the following data of values of x and y. From the following data of values of x and y, find the regression equation of y on x. Find the regression equation on y on x. Okay. X values are, okay, there are two values. X values are, they are given 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And y values are 3, 5, 4, 3, 5, 4, 3, 5, 4, 8, 9. Okay. Okay. We are going to fit a straight line of the form y is equal to a plus b. They are asking about the y on x. We can start. Let the recursion equation on y on x. Let the recursion equation of y on x be. Let the recursion equation on y on x be y is equal to a plus bx. Let the recursion equation on y on x be y is equal to a plus bx. Let the recursion equation y on x be y is equal to a plus bx. The normal equations are okay, fine. Okay, last day we discussed how to fit a straight line of the form y is equal to a plus bx. Okay, a plus bx. The normal equations are sigma y is equal to na plus b sigma x, and sigma xy is equal to a sigma x plus b sigma x squared. We completed the problem.
Yes,
We
sir.
completed. Yes. What is a? What is a? What is the value of a?
Minus 1 by 5.
Minus 1 by 5.
Minus 1 by 5. What is b? What
3
is
by
b?
2.
3 by
3 by 2. Okay. So our equation is y is equal to minus 1 by 5 a plus bx. Okay. 3 by 2 x. That is our best fitted line by the method of least squares. Okay. This method is known as the method of least squares to find out the best fitted line. The least squares means sum of the squares of the deviation from the observation is minimum. Okay. So using that principle, we find out the normal equations and we got the regression equation as minus 1 by 5 plus 3 by 2x. Okay. This is one method. Another method is that you can do the same problem in another method. The method is same. What we are doing, we are using this equation. We have to find out the values of a and b. So from this equation, we can write what is a. Okay, na is equal to na is equal to sigma y minus sigma y minus b sigma x, or a is equal to sigma y by n minus b sigma x by n, or a is equal to, what is y by n, sigma y by n, that is known as y bar, our arithmetic mean, and b into x bar. So we got the value of a. Okay. So similarly, you can also find out the value of b solving these two equations and substitute in the equation y is equal to a plus bx. So we get another equation that is easy for you to evaluate because there is no need of using this normal equation. Okay. What we are doing is we have to find out a and b solving from this equation like that. We got a. Similarly, you can find out b. Okay. There is no need of worrying b or a. So I will write the final answer. So the regression equation on y on x is so another form or second form, that is y minus y bar. Y minus y bar is equal to byx into x minus x bar. Okay. Another method of doing this problem is easy for you. Okay. Where you know what is y bar. Y bar is equal to sigma y by n, the arithmetic mean, and x bar is equal to sigma x by n, and byx is equal to, okay, byx is equal to, okay, byx is equal to, there is a formula for byx because after solving we get this equation. So, okay, byx is equal to n sigma xy minus sigma x into sigma y by n sigma x squared minus sigma the whole square. Okay. So you can write another method of finding, another method of fitting, another method of fitting rectification on y on x. Another method of fitting regression of y on x is y minus y bar is equal to byx into x minus x bar. Y minus y bar is equal to byx into x minus x bar, where y bar is equal to sigma y by n and x bar is equal to sigma x by n. Okay. And byx is equal to n sigma xy minus sigma x into sigma y divided by n sigma x squared minus sigma x the whole squared. N sigma xy minus sigma x into sigma y whole divided by n sigma x squared minus sigma x the whole squared. Okay. So regression on y on x, you can apply this technique in examination. You don't worry about applying the another equation because you have not difficulty in solving a and b. So here there is no need of finding a and b. Directly you can substitute here and simplify, and we get a form y is equal to a plus bx. Okay. You have to write in the form y is equal to a plus bx. That's a regression on y on x. Completed? Hello, completed?
Yes, sir.
Yes. Okay. Similarly, regression equation on x on y is equal to, regression equation of x on y is equal to x minus x bar is equal to byx becomes bxy. Okay. Bxy into y minus y bar. Okay. X minus x bar is equal to bxy into y minus y bar, where bxy is equal to numerator is same, there is no change, n sigma xy minus sigma x into sigma y, but denominator will change. It becomes n sigma y squared minus sigma y the whole squared. Okay. Sigma y the whole squared. Okay. Byx, x will come down. Okay. Bxy, y will come down. Numerator is say easy to remember. Numerator is same, but denominator will change. Who is coming? The second will come in the denominator. Okay. Here bxy, so n sigma y squared minus sigma y the whole squared. X bar you know sigma x by n, y bar you know sigma y by n. Clear? So it is easy to find two regression equation y on x and x on y. First equation y minus y bar is equal to byx into x minus x bar. Second equation is, and you have to write and simplify it in the form y is equal to a plus bx form. Okay, a plus bx, and this is you have to simplify and write in the form which form? X is equal to c plus dy. Okay, this is the original form. X is equal to this equation on y x on y. Okay, c plus d. After finding, you have to simplify it. X is equal to c plus d. This equation you have to simplify y is equal to a plus bx. Byx and bxy are known as byx and bxy are known as byx and bxy are known as regression coefficients. Okay, regression coefficients. Byx and bxy are known as regression coefficients. Okay, regression coefficients. By and bxy are known as regression coefficients. Please write a question. Find regression equation on y on x. Find regression equation on y on x and x on y. Y on x and x on y from the following data. From the following data. Find the regression equation on y on x and x on y from the following data. X, okay, 5, 6, 3, 5, 6, not 3, 7, okay, 5, 6, 7. Any value you can put, no problem. 5, 6, 7, 3, 2. Okay, y. Y is 4, 5, 8, 4, 5, 8, 4, 5, 8, 2, 1. Okay, 4, 5, 8, 2, 1. Okay, 4, 5, 8, 2, 1. Okay, first of all, we write, please write regression equation y on x is equal to regression equation of y on x is equal to what's the equation? What's the equation? Come on, y minus y bar is equal to
B
y minus y bar is equal to byx into x minus x bar. Y minus y bar is equal to byx into x minus x bar, where byx is equal to n sigma xy minus sigma x into sigma y whole divided by n sigma x squared minus sigma x the whole squared. Then regression equation on x on y is equal to, or we can complete then second we can do. Okay, so what are the things needed? Okay, the columns stand needed xy, x squared and y squared, all find out. Okay, and here you have to write the notation strictly sigma x, sigma y. Okay, in assignment nobody is writing the notation. Notation is very important. Sigma xy, sigma x squared and sigma y squared. Find out all these things. Speed up. Sigma x, sigma y. Find out all these things. Speed up. What is sigma x? What is
23.
sigma x?
23.
23. What is sigma y?
20.
20.
20. Sigma xy?
114.
14.
40.
114 or 114.
114.
114.
Oh, okay. Sigma x squared?
123.
120. And sigma y squared?
123.
123.
120.
Not-
Okay. 123. Okay. Okay. We got all this. So we want y bar. First of all, you have to find out y bar. Y bar and x bar. Okay. What is y bar? Y bar is equal to sigma y mean. That is arithmetic mean. And x bar is equal to sigma
Sir,
x by
sigma
n.
x
Find out.
squared is 123.
Sigma x square is equal to 123.
What is sigma
And
y
sigma y
squared?
squared is 110.
114.
110.
Ha. All are getting different answers. Xy is equal to 140. Okay. Sigma x squared. Sigma y squared 110. Correct.
110.
What is sigma x squared? Am I correct? 123?
110.
Sigma x.
Yes, yes.
Yes. Okay. Okay. What is y bar and x bar? You can find out. Okay. Y bar is
Y bar
20
is
by 10. Okay. Is it 10? 2, 4, 5.
5.
20 by 5. That's equal to
4.
4. Y bar is equal to 23 by 5. What is that? 4.6.
6.
Am I correct? Okay. Then Byx you can find out. Byx is equal to n sigma xi n into xy is 114 minus sigma x into sigma y. 23 into 20 whole divided by n sigma x squared. Sigma x squared is 123. Okay, sigma x the whole squared. That is equal to 23 the whole square. Find out what is value. Okay. What is b by x? Got it? No.
1.27.
1.27.
1.27. Okay, 1.27. Okay. Then we can write regression equation on y on x is y minus y bar is equal to Byx into x minus x bar. That is 4.6. Okay. Simplify. You have to simplify this. Okay. So simplify, but how to simplify? Y minus 4 is equal to, okay, 1.2 into 1.27 into x. Okay, 1.27 into x minus 1.27 into 4.6. Find out that. Okay, y minus 4 is equal to 1.27 into x. What is 1.27 into 4.6?
5.84.
5.8. Okay, is equal to 5.8. Okay, constant to the or y is equal to, because a plus bx form. So 1.27x minus 5.8. It will go to the right hand side. It plus
Plus.
4. That is equal to. What is that? What's the difference? So take the difference and put the negative sign. What is that? 1.27x minus. What is the answer? Come on. Yeah, yeah. Yeah,
1.2.
Yes, 1.88.
1.88. Am I correct? Okay. Therefore, y is equal to minus 1.88, or this is enough if you want a plus bx form, 1.2x. Okay. This is the recursion case on y on x. Okay. This is the recursion case on y on x. Clear?
Yes.
Yes, sir.
Yes. Then recursion case on x on y is equal to recursion case on x on y is equal to x minus x bar is equal to x minus x bar is equal to bxy into y minus y bar. Okay. Where bxy is equal to, what is the formula? N sigma xy minus sigma x into sigma y. Bxy comes out n sigma y squared minus sigma y the whole square. Find out bxy. 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 Find bxy.
0.73.
Okay, 0.73 is the correct answer. Everybody got it? 0.73.
Yes, sir.
Okay, right. Therefore, recursion equation, we are going to write the equation. Okay. X minus x bar. What is x bar?
4.6.
What is x? 4.6 is equal to 0.73 into y minus y bar is 4. Am I correct? Yeah. Then simplifying, it is of the form x is equal to c plus d by 4. We are going to write in the form c plus dy. Okay. So x is equal to this tab to the right hand side. So before that you have to multiply. Okay. X minus 4.6 is equal to 0.73y minus 0.73 into 4. Find out 0.73 into 4.
2.92.
2.93.
2.93. So x minus 4.6 is equal to 0.73y minus, what is the answer?
2.9.
2.9. Okay, 2.9. Or x is equal to 0.73 y minus 2.9 plus 4.6. So x is equal to 73y. What is that? What is that?
1.7.
1.67.
1.7?
7.
7? Okay, 1.7. Therefore, x is equal to c plus d5. Constant will come first. 1.7 plus 0.73y. That is the recursion equation on x on y. It's a very easy question. You can